Hi guys, in this video we're going to look at how to create some simple animation with Java. So the first thing I want to do is to set up a new workspace so that we can clear away some of the rubbish from what we've been doing before. So if you go to File and then go to Switch Workspace and choose Other, and I think what we can do to organize the work is each time we start a new unit, we'll put workspace and then let's put the date. So I'm doing this on the 6th of October. So I'll put 6th of October 2020 as my workspace and then click launch. Okay, and Eclipse will restart. And once it's restarted, I'll have a clean workspace to work in. So it just helps to not get too confused with having a lot of old projects. Okay, so now once I'm starting with a nice new workspace, I'm going to click on Import Project and choose Git and Smart Import, and then Clone URI. Okay, now this is where you need to enter the URI, which I've got on my GitHub here. So it's https://github.com/lewis-cressy/tbs.git. Okay, and my password for Git has appeared here. You don't have to put in your password, but you probably already have. Okay, so now I click next, and then next, and now I'm getting an error here because the directory already exists for me. You probably won't get that error. So that's fine. So I typed a little bit extra just to get rid of that error, but you don't need to type anything extra. You can just leave it as it is. And then I'll click next. And then I'll click finish. Okay, so now we're ready to get started on this unit of work. So we need to make a new project. So I move over to here and press the right mouse button. Go new Java project, and I'm going to call this project exercises, and finish. Now I did choose Java 1.8 there, so please do use Java 1.8 for compatibility. If you didn't pick Java 1.8, you can check it here. Just right click on exercises, go to properties, then choose Java compiler, and you can select the level here. So if it doesn't say 1.8, untick that box, and then you can choose 1.8 from the options. Okay, I'll cancel that because I don't need to change it. Okay, so now we go to our source folder, right click, new class, and I'm going to make this my first exercises class. So I'll put and I'm going to tick that box so that it's a program which I can run. Okay, so that's the box that makes public static void main. And you might remember the reason we need public static void main is that tells Java that we want to start at that location. Okay, so now I click finish. And here's my class. Now there's a couple of things I need to do to make this work. And don't worry if you don't understand these at the moment, they will get covered later in the course, but at the moment I'm just going to say what you need to do. So the first thing is, after the says exercise 1, I'm going to write extends simple app. And simple app is underlined in red, but all I have to do is hover over it. Oh no, that's not all I have to do. There is one thing I forgot to do. So please right click on exercises and then go to build path and configure build path, go to projects and then choose add and click TBS, which is the thing that we imported from GitHub. Okay, once you've selected TBS, choose apply and close. Now you should find that when you hover over simple app, it gives you an option to import simple app, and that's the option that you want. So without going into too much detail, because like I said, this gets covered later in the course, but all we're doing here is that from GitHub, we imported simple app, which is a way to get up and running quickly with your application. If we didn't do that, you would have to write more code here and I don't want to give you a lot of code to write which isn't relevant to what we're studying at the moment. So this will just get you started. Okay, so then in my public static void main, I'm going to write new exercise brackets and semicolon. Now I can start writing program code here. I'll write public void main, but this time there's no static and there's no string args. Okay, so this is just normal public void main. A bit of text. So if I click on the play button, we should find that it does open a window where we can do some graphics, and it's also printed out hello down here. So I'll close the graphics window, and let's look at putting something into that graphics window. So I'll start off by just putting a point into the graphics window. I'll do screen dot set color. Let's have red color. And then screen dot plot. Now the screen is 400 pixels square, so I'm going to put it at 200, stick it in the middle, run the program, and now I've got one red pixel in the middle. Hopefully this is all making sense to you from what we had a look at in previous lessons. Okay, so now I'm going to write a for loop. Again, this is kind of like what we looked at in previous lessons. So x equals 0, x is less than 400, x plus equals 1. And then I'll plot at x, comma 200. And this should give us a horizontal line. So I click play, and there's my horizontal line. Okay, so I said that we're going to be doing a little bit of animation. It's not going to be super glamorous at the beginning, but it is still going to be some animation. So the simplest way that we can animate it is just to slow down this for loop a little bit. Okay, so I can do that. What I can do is write sleep, and then I have to put a number of milliseconds. So let's sleep for 20. Now what that's going to do is each time I go around the loop, I'm going to wait 20 milliseconds before I then plot on the screen again. So if I run that program, you should see that the line is moving very slowly across the screen. Okay, it's like I'm on a really slow computer, an Apple Mac or something, and then it's taken a long time for it to draw that line over to the right hand side. And by increasing the delay, I can slow it down even more. So if I made it 50 milliseconds, it's really going to crawl. There we go, going across the screen very slowly. Okay, now, guys, that is one way that we can draw on the screen in an animated fashion so that it changes gradually, okay? And this is actually the way that games used to be done many years ago. Back in the 1980s, this is how we used to do our computer games. But there are some problems with doing it this way. So what we can do instead is we can create another part of our code. I'm going to call it on frame. And this part of the code, instead of being run once at the beginning of the program, it will get run once every frame. Okay, so I'm sure that most of you already know what a frame is, especially if you're a gamer, but a frame is basically the image that is shown on the screen for just an instant. Okay, so on a typical computer monitor, we might be showing 60 frames in 1 second. And by changing what's shown in each frame just a little bit, we create the illusion of movement. Okay, so in this case, what I can do is I can put something into this frame, and it's going to be drawn every second. So let's take our plot code and move it down here. Okay, now you might think that that's going to draw a line moving across very slowly, and in a way it will, but this code at the moment is very broken. So I'm going to delete this part out, and kind of try to explain a bit why it doesn't work as it is. So I'm going to plot it 200, 200 again. Let's run the program again. Now you can see that the red dot in the middle is being plotted. Okay, I am plotting the red dot. What I'm actually doing is plotting that red dot 60 times a second. So of course it looks exactly the same as if I just plotted it once at the beginning, but that is running 60 times a second, and I can prove it to you by printing something out on the screen. So if I put print line hello and then run the program, you can see that it's really spamming hello in the console window down here. So that tells us that we are running at 60 frames a second. Well, maybe not 60 frames a second because this is Java, but at least we're running at some number of frames per second. Okay, so let's say that I want to draw my line moving across gradually. Well, we know that I want to use a loop for that, so I need a variable called x, and I'll put 0, and then I'm going to add 1 to x each time. Okay, so the idea is that I'm going to start off when x is 0, plotting a red pixel on the left-hand side of the screen. And then in one frame, I'll plot that pixel, and then I'll add 1 to x, and the next frame, I'm going to plot the next pixel along, and so on, until I get to the right side of the screen. So that would be a good guess. It's actually not quite what happens. So if I run the program now, you can see that that red pixel never moves from the left side of the screen. Now, the reason for that is that every frame, although I am plotting a pixel, the value of x is being reset back to 0. Okay, so x never changes. So what we need to do is we need to keep the previous value of x. And this is where what's called the scope of the variable is really important. So if I write int x equals 0 inside this onFrame method, that means that whenever I start a new frame, I create a new variable called x with the value of 0. That's not what I want to happen. I want to continue with the old value of x. So to do that, I have to move the int x equals 0 into a different position. So I'm going to cut it out of onFrame, and I'm going to put it at the top of my class up here. Okay, so it's the same code, but it's in a different location. Now what this means is that when int x equals 0 was in onFrame, that meant that I created a new x, and it had the starting value 0, and I did that every frame. Now that int x is inside the class, but not inside onFrame, that means that I create a new x when I create the class instead of when I do the onFrame. So the value of x, once it's been created, will keep its old value as I go from one frame to the next. If I click on play now, and now you can see that the red line is actually moving across the screen. When it gets to the edge of the screen, I'm going to get an error because it will go out of the bounds. There we go. Okay, so guys, this should give you an idea about how the place that I put a variable affects how long that variable keeps its value. Okay, so this is what we call the lifetime of a variable. So if I put the int x inside onFrame, that means that x only exists as long as onFrame is happening. If I put the x in the class, it means that x exists as long as this class exists. Let's see if I can add a little bit more to onFrame. So what I'm going to try to do is add a y coordinate as well. And what I want to do is make the dot move diagonally on the screen. So before I go any further, if you pause the video, you could have a go at doing that yourself. See if you can make the dot move diagonally. Okay, so here's the solution. I'll put int y equals 0, and then I'll put y here, and I need to add 1 to y as well. And when I run the program, now my dot is, my line is moving diagonally down the screen. Okay, that's fair enough. Now let's see if I can make the line bounce off one of the edges. Okay, so I'm going to increase the value of the starting value of y. I'm going to put 50 here so that the line starts from a little bit lower down the screen. And what I want to happen is that when the line gets to the bottom of the screen, I want it to actually bounce at right angles and come up to the side of the screen. So to do that, I'm going to add a third variable. I'm going to call this variable dy, okay, and that's going to measure how much I add to y each time. So here I add 1 to y, so I'm going to make dy 1, and then I'm going to put dy here. Okay, so I'm still doing the same thing I did before. I'm adding 1 to y. The only difference is that I've stored that variable, I've called it dy. Why would I do that? Well, the reason is that when the line comes down, I'm adding 1 to the position of the pixel all the time. But because it's stored in a variable dy, it means that when it gets to the bottom, I can actually change the value of dy and start the pixel moving in the opposite direction. So let's see how I can do that. I can say if y (100), then I want dy to equal -1, and then remember that 400 is off the screen, so what I'll need to do is actually, well, I could add dy back to y, or maybe I'm going to cheat and put 399 here. Okay, so now let's have a look at it and see what happens. So the line moves down, y is increasing, is getting closer to 400. Now when y gets to 399, suddenly the line bounces, okay, because I changed the value of dy to -1. That means that the line is moving up instead of down because I'm adding -1 each time to the y coordinate. Okay, so this should give you some idea about how we can manipulate coordinates. What I would like you to have a go at doing is to continue this pattern. So what we're going to do is we're going to have a line which moves down, it hits the bottom, it bounces off the bottom, it hits the right side, it bounces off the right side, it comes back up to the top, bounces off the top, and then eventually it's going to draw a kind of rectangle in the screen, a rectangle made of diagonal lines. Okay, so that's a bit of a challenge for you to have a go at, and I'll leave you with that. That's the end of this video.